Alright, hello people. I can never quite tell how long I have to wait after I hit the start stream button to actually start talking, but hopefully that was a good pause. So, today we're just going to keep working on this lesson 2. I think that the new draft is almost done, and maybe we could even finish it today. And then I can post it on, the Git repository for these lessons and start getting feedback from the rest of the team. Where to go with it next. I want to reread a little bit of what we were doing last so I can remember. In this one we can see a diagonal gradient similar to the x plus y case. But to understand this case, we have to consider what happens when y is greater than x. In that situation, x minus y is negative. How does that work? The answer is that negative results wrap just like positive results. Well, that all needs work. I would write something totally different now, but I'm not going to make any edits right now. So, oops, that's wrong though. This should say negative 256. 5, 4, 3, 2, 1. Okay. So 250. It might be a little odd at first to think that negative 1 wraps at 255. But there's a good reason why it should work this way. Remember that the rule for wrapping is to look for the next multiple of 256 down from the current value and then find the distance. For negative 1, the next multiple of 256 less than negative 1 is negative 256, and the distance from negative 256 to negative 1 is 255. Alternatively, if we think of 256 as equivalent to 0, since it wraps 0, then it should also be the case that 256 minus 1 is equivalent to 0 minus 1. Otherwise, we cannot replace 0 6 with 0 in any computation and still get the same result. Croifa, Darren, Sweeney, welcome to the chat. So now we can see why there's a diagonal seam in the x minus y case. It is caused by the negative wrap where x minus y equals negative 1. It is caused by... Okay, I don't think this is quite right. This diagonal seam exists along the set of points where x minus 1 equals negative 1, thus causing the computation to wrap back to 255 and appear white. Hey, Flying Solomon, welcome back. Alright, so now I remember where we were. Alright, I want to put in like this, kind of a heading here to split these up because they're going to be kind of long. This first image shows, and this is the x squared case. I want to pull up the code like I was doing last time. X times x, and can I use CL painting.c? Alright, I need to do setup CL x64, CL painting.c, and then painting. And then if I pull open that folder, oops, yep, this folder right here, then I should be able to see this. I don't want Photoshop to open it up. I'll open it up like this. Alright, so that, right, I have to make sure I remember to save this. You know, I could save myself a lot of time if I would just make a build.bat for this. Because now I can do Alt-M. Right. Build.bat, setup CLX64, and that should avoid the problem of me forgetting to save every time. Painting. Still looks the same. Okay, so here's the question. Did that actually save my file? Yes. So I build it. I run it. No change. Okay. So that's not working. Let me just take a minute to try a different plan. New project, painting.c, output right here, painting. Alright, now let me see here. Yeah, let me load that project and see if that works. You know what, I have a different idea. Let me close this. Now that I have a project set up here, when I start 4Coder it should load that. Okay. And there we go. Alright, there we go. Man, that stupid CL thing, if I could fix that, it would get rid of so many little wastes of time. Okay. As long as I'm going to be using a 4Coder project, I might as well throw Markdown in the mix there so that I pull open my draft next time. Alright, so now I can build this the way I'm used to building it, and I just have to remember to take all this stuff out before I push it. This is still the same. Okay, so I want to make sure I run it still. There we go. Alright, well that took a little while there, but now we're getting it. So, yeah, what this one basically shows is vertical stripes, that's what I want to say, where the intensity of the stripe is equal to the x coordinate squared. we can see on the left edge that the gradient grows smoothly for a little while before it starts wrapping. Then it wraps many, many times from left to right. Like addition and subtraction, the wrapping rule here is just like for addition and subtraction. After doing the only difference is that the numbers from multiplication resulting from addition get so high that they cross the wrapping boundary sooner. If we zoom into the image, we can see that the x-coordinate, x equals 15. Doubter, Mojo Bojo, heyo, how's it going? It's going alright for me. By the way, people here on the stream, I think since people are here right now, now might be a good time to let everyone know that I'm not streaming next week, and it'll in fact be a few weeks before I'm streaming again, and that's because I'm moving. I won't be set up in this office anymore. And so while I'm going through that, I'm going to be a little bit incognito on the internet until I am completely set up on the other side. But for today we can get this done. If we zoom into the image, we can see that the x-coordinate, at the coordinate x equals 15, that the result still hasn't wrapped. 15 times 15 equals, what does that equal? 225. So that makes some sense. 16 times 16 equals 256. So at x equals 16, the first wrap has occurred. So it makes sense that this is the first wrap. Alright, so first I'm going to answer the on-topic question, then I'll answer Karifa's question. To Too Legit to Quit asks, how is this different than Casey's first 5 Handmade Hero, Intro to C for Windows lessons? Do you go further? So those lessons, I mean, if you watch them, they do have some good information there, but they're not really meant to be a comprehensive Intro to C from first, like from no understanding of programming to understanding it, or from no understanding of C to understanding it. Like that, he's even said that they're just not really a full intro. They're more of a test stream. This is also not meant to be in video form. I'm streaming, but I'm streaming me writing it. The final thing is supposed to be in written form so that you can deal with it at whatever pace you want and reference things, and so that it can be improved over time by the community. And yeah, it's going to go much further into everything. The very first lesson, the only programming you do is to test your compiler and learn about what your compiler is doing. The second lesson is all about the various arithmetic operators and experimenting and playing with them and just combining very basic math stuff, so that your knowledge about math, about arithmetic, can be brought in, and you feel like the world is becoming, like you're not immediately thrown into somewhat more foreign parts of what programming is. I feel like, a lot of lessons try to start with introducing the idea of what a variable is, and this is more aimed at giving you just some playground to play with and showing you the ways to play with it, and letting you kind of learn those subtle things about what a variable is just as you play with it, before trying to make it explicit at least. So it's meant to take smaller steps more gradually and cover more ground. As far as what side of the planet am I moving to, well, I don't know how we want to define sides. It's northern hemisphere. Depending on how you define east and west hemisphere, I'm going to be in a different time zone. I'll be moving to the west coast. I'm moving to Seattle, basically. If you want a very specific position, and then you can figure out what side that is from there. Too Legit to Quit asks, when will it be released? The first lesson is ready, except that I haven't rewritten it for the Handmade Network site to have a few things that it needs to have to integrate fully, like final image hosting, you taking advantage of the asides that are there now, like a final pass still has to happen on lesson 1. Lesson 2 is almost ready. The second draft of it's almost ready. I think today we'll finish the second draft, hopefully, and then we're going to put it through a little while, a little bit of a review, like from the team, for a little while, and see if this is a good direction, and then it'll go up. But after that, no more lessons are even totally really written yet. So there's going to be a lot of these, and they're going to come out gradually. As far as when will any of it be released, I bet it will be soon that you'll see 1 or 2 lessons, and it's going to be a long time before you see the full set of them. I think it'll go past the end of this year, getting all of them ready, and into 2019. All right. Alright, so there we go. We have Thorder A asks, do you have a CS degree? No, I never graduated from college. I was about a semester away from finishing my degree when I left because I was out of money, and I went and got jobs for a while, and now I'm getting now the kind of work I'm doing is the work I would want to do anyway. Like, I would only need a degree to serve the goal of someday doing the work that I'm doing, so I don't see any reason to go back and get that now that I'm doing what I want to do. Doubter, yes, I can show you the this thing actually. I worked on it a little while ago. Roadmap. So one of the last lessons in the series for beginning is all about debugging series, and the first one is designed, like the first big part of it's going to be designed so that you can use it no matter what tools are available to you. It's basically ways of debugging with printf and methods like that. Then there's going to be a specialized one for using debuggers. Questions about forcoder? Yeah, you should get your builds at itch.io and for updates you can follow the blog. You can either follow there, where I will post devlogs there, and I will post blog posts on Handmade Network as well. Okay, so let's get back onto this. Oops, when did I do that? Don't do that. Alright, so now alright, so with that we have addition and multiplication out of the way, or subtraction and multiplication. Alright, finally I want to look at division and modulo. The last two operators we need, arithmetic operators, we need to look at are a bit dangerous. I don't like that. Well, have to be used with some care. There are two big limitations to division. 1. It is not allowed to divide by 0. 2. Because our numbers are all whole numbers, division usually involves, often can cause the result of division is sometimes rounded whenever it has to be. Okay, so now the question is, first let's look at the behavior of rounding by examining this, the image produced by this computation. X divided by 4. Well, I want to make it even wider than that. Let's do like 8. That leads to a really dark picture because it doesn't get very large values. Let me try and just experiment a little bit here. I want it to clearly, okay, now it's clearly getting brighter, but it's not as bright. And the bands are only visible if you're really zoomed in still, I think. Maybe if I divide by 6 and I start with something larger. Still can't quite see what I wanted to see. Let me get that divided by 8. Let me take x divided by Doubter, the bug you reported, it still isn't fixed. I haven't posted any new versions since then. In fact, I haven't posted any new versions since, like, November. And what's the matter with GCC Line Jumping? I don't know what the problem with it is. commands are still too small. I'm not sure I can get what I want here. Alright, then I'm just going to go with this version. Yeah, that'll be good enough. Yeah, okay. So that idea still will work. It's not quite visually obvious, but it'll work. Yeah, you should be able to send me an example of your compiler report, Stouter, if you haven't already. GCC line jumping does work, unless it's a weird format that I'm not handling. It also does only work if you're using full paths to your files. Yeah, it won't work with relative paths, because it has no way of knowing what that path is relative to. Clang has the same format. It's fine. The line formats is detecting them. The reason it's not jumping is because it doesn't know how to find the file. The hard part is GCC and Clang don't give you a flag that gives you full paths. The only way to do it is to get the full path to the file you're passing in. And if you're passing in lots of files, that's a big pain in the butt. At some point, I wish 4Coder could know how to do that, but it would have to take over and control the build system so that you don't actually get to write the command line, because since you're writing the command line, there's no way for it to know where to look as potential routes for the relative files. Alright, looks like you got your situation figured out. That's good. That's cool. Alright, let's keep making progress. First, let's look at the behavior of rounding by examining the image produced by this computation. For one thing, we can see that it still forms a gradient from left to right, but the colors never get close to white, because W never gets close to 255. If we zoom in, we can also see that the first 4 columns of pixels, where x equals 0, 1, 2, 3, are all black. The next 4 columns all have a brightness of 1, and so on. This happens because the numbers are rounding towards 0. When x equals 1, 2, 0, 1, 2, and 3, the division by 0 cannot be answered precisely. So instead, the result is rounded down. If we wanted to find out what the remainder, if we recall, so if we took the result and multiplied by 4, we would not necessarily get back the original x. In other words, x divided by 4 times 4 is not always the same as x. We can see this for ourselves. Yeah, Doubter, you're right. It does skip the first line. The only reason I haven't fixed that is because I'm a lazy ass sometimes, and I don't want to. I know about it, though. It doesn't ever hit me, so I haven't got around to it. I'm always torn between, because one thing I could do is just say that I'm locking down and just fixing bugs for the rest of time, but I really want to get there's one sort of big vision that I have that isn't in there yet, so I'm not doing bug fixes, and the next time I work on 4Coder, I'm just going to push straight ahead towards where I want it to be, and I'm kind of going to just let the latest version stand indefinitely without doing any bug fixes until I get to the internal situation that I want, because it's taking too long to get there with all the stopping to fix bugs and things, and I feel like it's at the point now where if the people who want to use it are happy with it, then that's great, and if it's not good enough for you, well, it's, then use something else, because it's not worth the time it's taking to keep fixing bugs on systems that are not even permanent. When I'm trying to get to the, and yeah. I want to get to a point where I can work on stability, and I can't if I haven't built the core thing that I want yet. Anyway, this is actually the image I was looking for originally, and it's funny that I found it by explaining things. Like, in the act of explaining what I was thinking about in my head, I finally found the kind of image I was looking for, where you see very distinct bands of pixels, right? Makes me wonder if something like this would work. Yeah, now is really strong. Here, if division had infinite precision, then the above computation would be the same as the gradient produced by computation w equals x. I'm going to just shorten it to that. But here we can clearly see bands of 8 pixels wide, that are all the same value. This happens because first, x over 8 is computed and rounded down if necessary, and then multiplication by 8 is applied, to the rounded value. Alright, so that gives us the idea of division and then rounding down. Also want to do modulo. If we think about the operator called modulo, helps is closely related to division. Basically, it answers the question if this division was applied, how much rounding would there be? For instance, since 3 divided by 8 rounds to 0, the amount of rounding is 3. (11 divided by 8 rounds to 1, and also has an amount of rounding equal to 3. Therefore, 3 modulo 8 equals 11 modulo 8 equals 3. Modulo basically lets you can make a table showing the results of modulo by 8. The following is a table showing the results of modulo by 8. Alright, so we want to do 1 modulo 8 equals 0. Two, three, 4, 5, 6, 7. One, 2, 3, 4. I thought I had enough. I was off by 1. Whoops, I screwed that up. Whoopsie daisy. I knew there was a reason that it was odd that I had to expand the table a second time. I was like, I thought I had thought this through and that I only needed to expand it once for the extra digit. 6, 7. Later, Koetha. Thanks for coming around. Bye, Doubter. Alright. If it feels like this concept is similar to wrapping, the wrapping that happens at 256, you're right. The result of applying modulo 256 would after all computations are done, if the result doesn't fit inside a byte, a modulo of the part that is kept, the value that is kept is equivalent to what you would get if you applied is the result modulo 256. ABDCW, I am working on teaching operators, and we're basically wrapping that up. The only thing I have left to do at this point for introducing them is to the caveat that division and modulo can't be by 0, and then I will have finished introducing them. That won't completely finish the lesson, but it'll be very good progress on it. But before I do that, I want to go look one quick thing up. Alright, so I want to take a look at how many words this thing is so far. Alright, so it's scoring pretty well on readability. Takes 16 minutes to read through all of it. Sentences, syllables, word count, 3,000. Alright, so this is going to end up being somewhere around 4,000, maybe 3,500, maybe 4,000, maybe 4,500 words, something in there. Alright, that's pretty good. That's right about where I would want it. Alright. Between these operators, let's do this first. if we just apply a modulo of 8, we will get pretty small numbers. And we could take a look at this operator by doing something like this. But do that, just see that the image turns out nearly all black, or turns out very dark everywhere. Since the result of modulo 8 is always less than 8, our pixels would never get very bright. Instead, let's take a look at it with an extra multiplier. Let's apply modulo and then a multiplier to make the sum of the pixels brighter. Alright, I'm going to use a multiplier of 32. Alright, and then let's see, we're going to take a look at the picture we get out from that. Okay, paint. And there we get exactly what I would expect, a bunch of small gradients increasing from black to white. I'll make that smaller so that it doesn't go quite to white and look like it's wrapping. That doesn't look like it worked. Hold on. What went wrong here? I said, oh, I didn't change the actual code. Okay. Yeah, that looks good. When using division and modulo, we also have to be careful not to divide by 0. If you write any of these, your painting program will crash. verify that. I kind of did this test a while back to make sure I was right that this causes a crash, but I wanted to just test again. Yep. Yep. With the first two, it is obvious why they are crashing. But what about the third one? Why does it crash? It turns out, the problem isn't just writing vision 5 by 0. Anytime the number what happens is that the variable y equals 0 for some pixels in the image, and at that point dividing by y is dividing by 0. This is why we have to be careful to check our divisors whenever we use these operators. If we want to study the image for x divided by y, we can use the following technique to safeguard the division. This uses features of the C language that we aren't quite familiar with yet. So if just gonna skip it. As you can see, this one turns out to be more complicated than things have studied. This turned out more complicated because we wanted to use a conditional step to make it work. We won't investigate this any further for now, since we are not ready to focusing on conditional steps in this lesson. Alright, in order to make that really work, what I would want to do is, after dividing, I would want to multiply by it too. Yeah, this is the one I wanted, because it's all cool looking. So this has division by 1 on the first two rows, and then division by 2, 3, 4, and then so on. 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Here, this one at 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yep. I find it fascinating because that's it's just neat to look at, because that's a single row of pixels that exactly models the whole picture, and just need to see it lining up with the other ones and things. Anyway, so that should conclude introducing the operators. Now I want to introduce a new section from scratch that's going to take those operators, and we're going to look at the assembly from them. So I'm going to switch this back to the way it was before. X plus y. And I'm going to switch over to math.c. I'm going to switch build.bat, no, not build.bat, project. Yeah, so, oh, I should run F2 to do that, but I'm going to do another one while I'm using this. Build math, build.bat, listen to build math.bat. So we want here is math.cpp, right? Math.c. That's going to come out, well, I don't really care how it comes out there. What is the flag for Visual Studio that makes it come out with assembly? Alright, let's try it. Cool. Cool. And then lesson 2 draft. Yeah, so a little nervous to write much of this on this setup because I really wanted to fit a GCC compiler's output. But I can get the basic structure in place, I think, or at least start writing the overview and then wrap it up for today, which makes this a shorter stream than I've done before. But yeah, this part here is mostly just going to be a shorter section walking through examining all of these things in assembly. Let's see, where is main? It's right here. Stack pointer, or frame pointer, or whatever. Moving the 10 and the 25. Into I see. And then we move those into registers. We add them together. We move that into EAX. Then we move that into the W. And then we call the IO functions and whatnot. So how should I introduce this segment? Just sort of thinking slowly here to myself. I'm sure it makes for great great watching on YouTube, and all this me sitting here staring at the screen thinking to myself. But hey, that's what it is. So I don't mean to look angry. I've noticed that before. I look super angry on my YouTube videos. I'm not actually angry. I think that's the scowl of my focus. And also the angle of the camera a little bit. Like it's up here looking at my brow. If it was like right here maybe it wouldn't hopefully look quite as angry. Maybe I just have an angry looking face too. I don't know what to do about that. Unfortunately, that camera position, I can't maintain it because I have to put it on top of something, and that was like right in front of I was just holding it here. There's no good way to make it work. What can I do? Alright, before we investigate the assembly, we need to make sure we can produce it. Yes, produce it. The result should look like this. Gotta do that. This is where it starts getting hard to write this without using the great assembler, because I don't actually know what it looks like. So pulling out the correct thing and saying this is the part that's actually doing the addition is going to be tricky. Like the last assembly we wrote. we produced. This is longer, and look, this longer and looks more complicated than the contents of math.c. I might also just paste that into the lesson though, because of how simple it is. Let's start by producing the assembly. Again, I want to get the real one from the GCC version later. There we go, that changed there. Very good. Da da da. So we not sure why it's XORing EDX. Maybe it's got something to do with the division, but anyway. Div appears to divide EAX by whatever you put there. Interesting. The use of the result of the same divide operation. Alright, now I'm in busyness. Probably too late, but better later than never. I'm not sure what you're talking about. Alright, I'm going to leave them with a couple more experiments to try where things get more complicated. Like what happens if we do x plus a particular number, right? What happens if I do that and then I multiply by y? What happens if I do x plus y and then I multiply by a particular number? Yeah, so I'm not actually trying to teach assembly details here. What I'm trying to do is encourage the reader to explore and learn these things on their own. Obviously, to see the RDX and RAX and all that, they would have to use 64-bit numbers. And right now I'm just having them use bytes. But that's the other fun thing, is as the lessons go on, the next thing they're going to look at is types. And so they're going to see signed types, and they'll be able to compare whether or not signed types use different instructions from unsigned types. They'll be able to use wider types, 32 bits, 64 bits, see how that changes things, and floating points, and see how that changes things. So the idea is to show a thing in the language that is sort of one simple concept, like here are the operators, and then investigate that in the assembly, and then we're going to introduce types, and then we'll learn that in the assembly there's not really types, there's just different instructions, or different uses of the same instructions, and things like this. And the hope is that by seeing those all the way through, they can build up an intuition for the connection between what the code they write is and what it actually does on their CPU. That's the hope. Alright, we're about ready to wrap it up for today. I think this is my first draft ready to go. I want to add in a conclusionary section So I'm going to pull up lesson 1, draft 4, and see how this one concludes. What is lesson 3 going to be about, by the way? Roadmap. Lesson 3. Painting with C. Using types. Data types. And color. And using more data types. Next time we will continue experimenting with painting.c to study ooh, that's a problem. Those should say there we go. Types. Use numbers outside the range. Types which give us more ways to use the memory our variables. With this new information, we will be able to also expand our paintings to use colors instead of just gray scales. Alright, there we go. Everything should be saved now. So that will wrap it up for today. I think this was a pretty good session. I finished the draft for lesson 2. Tomorrow I am going to probably miss the oh, there isn't a new meeting tomorrow, is there? Well, I'm going to tomorrow try to post this to start getting feedback. I don't know if there will be a meeting or not, but either way, this will be up on the GitHub for the people who are going to start reviewing it, and maybe next time I stream I'll have feedback and we'll work on that, or maybe we'll work on lesson 3. Either way, thanks for coming and chatting with me today, and see you guys around.